Navigation. An airplane is headed due west at a bearing of 270 degrees. So you see we've got our compass here, and the airplane vector is going directly to the west. It's 270 because when we're doing bearings, we start from north, which is the positive y-axis, instead of the positive x-axis. So normally we think of this line as being 270, but because it's bearings, we do from here. Okay. Airspeed of 250 miles per hour. So we're actually dealing with velocity, and that's a vector. So the airspeed, so velocity is a combination of direction and speed. So they gave us the direction and they gave us the speed. So this is velocity, which is why they've labeled it V1, because they're talking about velocity. So that's 250 miles per hour. The airplane going that way. Okay, the wind is from the north. So it's coming from the north, means it's going that direction toward the south. So that's a 180 degree bearing there. Because this is 270 and that's 180, it makes a nice right angle. So here's another right triangle problem, although that won't always happen with navigation. 30 miles per hour. So this little vector here is 30 miles per hour. Find the drift angle. So the wind is going to push the plane off course, and that is called a drift angle. The ground speed. Okay. The airplane, if it has a speedometer, do airplanes have speedometers? Probably. I don't know. If it has a speedometer, the airplane speedometer is saying 250, right? 250 miles per hour. But if somebody on the ground was like timing the airplane, or maybe, I don't know, do radar detectors work that far? Anyway, figuring out the actual speed of the plane from the ground, the wind is going to change that a little bit. In fact, I think it will speed it up because it's a hypotenuse, so it'll be a little longer. The wind is actually going to speed up the plane. So the speed from the ground is going to seem faster. The drift angle would be theta, the little angle that is different from the angle the plane thought it was going. And the course is the actual bearing. That angle there is the course. Does that make sense? Okay, so we are trying to find this resultant vector, which just happens to be a hypotenuse. So we have the legs. How do we find a hypotenuse when we have legs? Yeah, you could just use Pythagorean theorem, couldn't you? So the V3 speed we're looking for squared would be equal to the airplane speed squared plus the wind speed squared. So that's the square root of 250 squared plus 30 squared. Find that answer for me. 251.8 miles per hour. Okay, so it really isn't affecting the speed very much. However, it would, if it was flying a long distance, it would affect its time, right? Like if you're trying to keep on a schedule for an airport. So it still would have some sort of effect. Alright, now we do the angle theta. We have all three sides. But the most accurate way to find theta would be to use the two sides that are given that is not a rounded answer. So we have the two legs. Which tangent sine or cosine is best to use if we have the legs that we want to use? Tangent, perfect. So tangent of theta would be, we're looking at this angle here, the drift angle, so opposite would be 30 and adjacent would be 250. So to find that angle, we do the inverse tangent of 30 divided by 250. Okay, so find that answer for me. Okay, so the drift angle is 6.8 degrees. So the airplane thought it was going directly west, when in fact the wind is blowing it 6.8 degrees off that course, putting it on a true course of what? How did you find that answer? Okay, so they thought they were at 270, but it was actually 6.8 short of that. So 270 minus 6.8 gives us an actual course of 263.2 degrees. Could that affect where the plane is going? Yeah, just a teeny change in degree at the beginning can affect the destination a lot, right, by the time you get there. So, okay. Next question. Is this helpful? Are you feeling good about these? Of course, I already have most of the pictures drawn for you, which is kind of maybe not a good thing because I'm not letting you practice. Okay, ignore that there's a picture. Oh gosh, okay. If I remember right, I think there are some pictures in the book. I don't remember. Has anyone done this assignment yet? And an airplane is headed due east. Okay, so let's really try it without the picture. I know yours is on your paper, but I'm going to try it without the picture. So if I have a compass, this is north, south, east, west. Due east is going this way, right? With an airspeed of 300 miles per hour. So what bearing is that anyway? That would be a 90-degree bearing. The wind is out of the northeast. That's weird. So the wind is blowing this way at a bearing of 225 at 50 miles per hour. But we actually want that to be at the end of this vector over here, right? So there's our 200. If you need to, draw a new little compass. Every time the plane changes directions. Didn't we do that one time before when we were drawing it? So then 225 is there. And this is 50 miles per hour. Okay, find the drift angle, the ground speed, and the course. So since the plane is going that way, but the wind is blowing it this way, it's going to go off course this direction, and it will actually be going slower than its actual speed. Okay, so we're trying to find the ground speed, so that would be this here. I could use S for speed or just call it X or whatever. And then we want to find this drift angle there. And then we want to find the actual course angle by taking 90 and adding the drift angle to it, right? Does that make sense? So we have two sides again. I think it will be pretty easy to find this angle. Because if this side, well, it was at 90, but now look at this little compass. That puts it at 270, right? So how far is it from 225 to 270? 45 degrees. Okay, so then we should be able to use law of cosines, shouldn't we? So our speed, S, ground speed, S, is the square root of 300 squared plus 50 squared minus 2 times 300 times 50 times the cosine of 45. What did you get? Do you understand how important it is that you kind of think through logically at your answers? What if you obtained an answer that was larger than 300? Then you know you did something wrong. Because based on our picture, we can tell that that side has to be shorter, and so the speed has to be smaller than the 300. So I got like 267, does that sound right? Okay, so now let's find the angle in here. How do we go about finding the angle? Law of sines would work. So we would have that angle over 50. So sine of theta over 50. What other angle and side should we use? Okay, so we're going to have to use our rounded answer. I think so. Okay, so sine of 45 over 267. So then we cross multiply. So theta is the inverse sine of 50 sine 45 divided by 267. 7.6 degrees. Okay, so there's our drift angle. So then how do we find the course? 90 plus 7.6, because it was at a 90-degree bearing and now it's drifted 7.6 degrees, giving us a course of 97.6 degrees. Okay, so all of these have been course and ground speed. Do you need to do another one? Do you want to try this one with that by drawing your own picture? What do you feel like you need at this point? Should we bother doing this one? Do you want 10, 15 minutes to just work? There must be a reason I put it on here, but it doesn't look very hard. Or maybe all I did was write down the answers. I don't know, let's look at it. The heading of a Learjet has a bearing of 320. Oh, I see why I did this problem, because it's a more difficult one to draw and set up and find the angles. I think I want to do this one from scratch too. Okay, the heading of a Learjet has a bearing of 320. So there's our north at 0. So this is 90, 180, 270. So the heading is over here at 320, which is 50 past 270, so a little bit closer to north. So that's 320. Okay, the wind is 70 miles per hour with a bearing of 190. Oh, they wanted to make this lots of fun, didn't they? So the wind is going that way, which is 190 degrees. If the airspeed of the airplane is 400 miles per hour, then find the drift angle, the ground speed, and the course of the airplane. Okay, so I drew this vector for the wind right at 0, but what do I have to do with that in order to actually find the resultant? Some people make the mistake of drawing their triangle here and finding that angle. Or is that correct? No, you have to make this into your parallelogram. It's very important that you make it into your parallelogram, which is why I usually just do another separate compass for it. But you can do it either way. Okay, so there's the other side of my parallelogram. So the resultant vector is this plus this, which is this right here. Whoa, my pencil lid broke. Okay. So we're finding that thing right there. And we're finding the drift angle. So the drift angle will be there. So after we find that, we'll take the 320 and we'll subtract the drift angle. Correct? Okay, and then this side of our triangle is, what was the wind speed? 70? Okay, so the hard part of this problem is finding the angle we need in the triangle, which is this one right here. Alright, since this angle was at 320 from this compass, what is the opposite direction of a 320 degree angle? What direction what would the angle be there? Would that help us at all? To know that angle? I think it would. Can I just take 320 and subtract the 180 so that it's going the opposite direction? Would that be right? What did you say, 140? Yeah, I think that's right. So this angle here would be 140 because it was going a 320 direction. So if we look at this angle, it's 140. Okay, and then this here went clear over to 190. The wind went to 190. So 140 to 190 is a 50-degree angle. So that wasn't that hard to find, but you have to think through it. You can't just use the 320 and the 190 to find the angle. I guess you could. There might be a different way, but that's just the way that popped into my head first. Okay, so now to find the course, again, it's just law of cosines. Do you see how actually drawing the picture, figuring out the angle in the picture is the hardest part? You guys have gotten good at law of cosines. That's the easy part. So 70 squared plus 400 squared minus 2 times 70 times 400 times the cosine of 50. Find that answer. And then you're going to do your law of sines again. Sine of theta over 70 equals sine of 50 over whatever you found up there. You find your angle, and then you take 320. And you subtract the angle to find the course. Okay, go for it. Finish the problem. Anybody have any answers they want to check yet?